Hey guys, you're watching Python tutorial videos on my YouTube channel, Python for Microscopists. In the last few tutorials, we covered a few of these deep learning parameters, including the loss function optimizers and the metrics. And let's finish this off by talking about batch size. And this is probably the most intuitive of all because it's self-evident, right? Batch size means the size of the batch. And where do we define this? Again, when you do model.fit, there are many places where you define, like even if you, for example, use data augmentation, there is a batch size there. And it may mean the same, but the implications are different, right? So when it comes to data augmentation, when you say batch size, it's basically, well, at a time, how many do you want to augment? Do you want to create? Which still is relevant to this because that's how many are going into the model.fit if you're actually using data augmentation as your input. If you're using just model.fit and not fit, your augmented data, then you're supplying your X and Y values, right? Your X training information, all the X training input and Y training. For example, my X train can be all the training images and my Y train can be all the labels for corresponding to those images. Now, how many of those do you want to load at once? That is what batch size is all about. So in this example, I defined it as 64 and everything else like epochs, I'm defining it as 3000. So let's just look at a closer look at batch size. It's not just how many images at a time, but there are certain implications. So let me quickly cover that, okay? So the batch size defines the number of samples. Obviously, that's in the batch, but that'll be propagated through the network, okay, before updating the model parameters. So after each batch, the model parameters are updated, okay? And in other words, a batch of samples go through one full forward and backward propagation in your neural network training, okay? So that's why batch size is very important. If you have very minimal or if you have very large, there are certain implications, okay? You need to have the right amount of batch size. And a quick example here, if your total training samples, let's say you have 3,000 images and your batch size is 32. Okay, and if you're doing it for 500 epochs, the total epochs. So what does that actually mean? Well, 3,000 divided by 32, because 32 at a time. Okay, so 3,000 divided by 32, which is about 94. In fact, it is 93 plus a few more images remaining, so the total would be 94. Okay, so it takes 94 iterations to finish one epoch. One epoch is when all of your data goes through the forward and backward. All of your data, all 3,000 of your images go through the forward and backward. In a batch, 32 goes through, which means it takes 94 iterations to finish one epoch. After the first epoch, it goes back and does the same. How many times? 500 times. That's what the total number of epochs is. Okay. Now, what is a good batch size? Again, I should have automated this slide. I'm sorry about that, but I hate slides with too much text, but let's stick with this, okay? Please look at line by line. First of all, you may not have a choice because you probably have a crappy system like most of us do. So you cannot just have the luxury of working with large batch sizes like 128, 256, or 512s. Okay, so you may be limited to small batch sizes based on the hardware that you have, which includes RAM and GPU. If your GPU is only 4 GB and you're trying to load like a whole bunch of images, that are, especially if you have large images. Let's say you have 512 by 512 images, and you're trying to load 64 of them, then you will be filling up your GPU or your RAM. Okay, but if you work with MNIST dataset where your images are 32 by 32, you can get away by using 256 batch size. Okay, so it is completely dependent on your local hardware. Now, smaller batches mean each step in the gradient descent may be less accurate. Remember, in the gradient descent, you're trying to find the minimum. So if you have a small batch, that's not representing a lot of your data, all of your data. It's representing only a small portion of your data, which means you may be inaccurate when it comes to gradient descent. Instead of going the right direction, you're probably going the wrong direction. You'll eventually find the minimum, but then it takes a little bit more time, okay? It takes longer for the algorithm to converge. The overall process may still be faster, but longer time to converge in general. Now, I took this line off, some of the reading material I was doing. So it looks like it's been observed that for large batches, let's say if you have like 512 batch size or 1K or 2K batch sizes, there seems to be a significant degradation in the quality. This is a weird way of putting a sentence. Let me summarize it. For larger batch sizes, the ability of the model to generalize apparently seems to be decreasing. Okay, you're compromising on that. So they say that, okay, smaller batch size is preferable. Not too small, not too large. So what is good? A 32 is appropriate, and luckily on most systems that is possible. Okay, even if you're using Google Colab, the free RAM and GPU that they actually give you, for 32, it's a good starting point for most images. If you plan on working on larger image sizes, then you can go down to 16. I have done that, but 32 is a good starting point. Okay, if you have the luxury of going to 64, that's also fine. So the summary of this whole thing is larger batch sizes result in faster progress in training. Larger batch sizes, but don't always converge as fast. Okay, now smaller batch sizes train slow, but converge faster. So to me, smaller batch size seems to be fine. Now, let me just quickly show you a few lines of code so that you can test this yourself on your own data if you want. But in this example, again, I'm using the same example from last tutorial, which is, let me uncomment this so you can see exactly what I'm talking about in case you haven't watched the previous tutorial. So we are going to generate a bunch of random data points. Again, to do that, I'm using scikit-learn datasets make blobs with 1000 data points centered around 3, which means we have 3 clusters, and the standard deviation being 2. Okay, so this is the data set, and now let's actually go down to the main part of the code. Again, very similar to the one I've used in the last tutorial, except here it's organized as functions. So first we are going to prepare the data. How? Well, our X and Y, the one I just showed you, is part of this preparing the data, and then Y is one hot encoded using 2 categorical. Again, this is to convert from integers to binary class. If you don't know what that is, well, I thought about explaining that, but that would deviate us. Just take this line and then run it in the command line right here, in the Python console, and see how the output looks like before and after. Okay. Anyway, so that's getting your data ready, and I am actually splitting it half and half as training data set, half as the testing data set. Okay, 50%. So out of 1000 data sets. Now let's go down to fitting the model. Again, keeping it very simple, just 2 layers. Dense, initial dense with 50, and then the next dense with 3 nodes. Okay, 50 nodes here, 3 nodes here. 3 because we have 3 clusters. Okay. And the activation is softmax. As usual, just like in the previous tutorial, I am commenting out this stochastic gradient descent being the optimizer because I'm using Adam as my optimizer here. But again, please test out, replace this Adam with OPT or SGD if you want to define that, and then see how things actually work out here. Okay, and I'm using accuracy as the metric and categorical cross entropy because this is a multi-class classification problem. I'm fitting the model, and let's go ahead and do it for 200 epochs, and batch size, I parameterize the batch size. And the reason I did that is the whole point of this tutorial is to see the effect of batch sizes. So later on when we call that, we run this entire fit for batch size of 4, 8, 16, 32, 64, all the way to 512, meaning for 512 it should be 2 iterations per epoch, right? Because we have 1000 data sets. Again, this type of code can really help you study the effect of various parameters pretty easily on this type of data again. Okay, so finally we are just plotting it into a 4x2, like we have 8 plots here, right? So we are arranging it into 4x2. I think that should be pretty much it. So let's go ahead and run this. And I should mention it's going to do 200 epochs for each batch size. So let me go ahead and pause this video and continue once everything is done. Okay, so it's finally done, and I wish you could see my screen when it was actually going through all of these epochs. In fact, if I scroll back, you can see it started off with batch 4, and it took forever. And then batch 8, not that forever, but still took some time. Once it came down to like 32, 64, 128, it was like super fast. Okay. in terms of updating. It still had to do 200 epochs, but then the number of iterations was only 2 for 512. The number of iterations was like only 3 or 4 for 256, right? So it was very fast at training, but look how fast these things converges. When I say converge, that means actually getting to a stable value of 82% or so in this case. Okay, so for batch 4, it was almost immediate, like about 20, let's say 25 epochs. The problem converged. Now I'm actually got a stable value. For a batch of 8, it was slightly more than almost like 50 epochs, right? Where does it stabilize? About 50. And batch of 16, you see how it's again around 50. And batch of 32 about 75 to 100. And batch of 32 in terms of real execution was pretty fast, because the number of iterations was smaller. And batch of 64, and you see batch of 512. Now I see a split between the validation and the training data sets, and then it took forever, almost 200 epochs for it to converge, as you can see. So these are the types of studies you can do by taking code something like this and then changing different parameters so you get a better understanding. No video is going to tell you all the answers or provide you all the answers about your data set, but this is the only way to learn. So I hope you learned something about at least batch sizes in this tutorial. Again, in the next tutorial, let's cover a different topic, but please subscribe to my channel so you learn content like this if you like it. Thank you very much.